The battle of metals, stainless steel versus titanium. Hey, engineering moms! Today we're going to uncover the secrets and applications of two of the most impressive materials used in modern engineering. On one side, the versatile and omnipresent stainless steel. On the other, the lightweight and ultra-strong titanium. Which one do you think is better? The answer, like almost everything in engineering, is not as simple as it seems. Have you ever stopped to think about the number of different metals that surround us? Each one with its own characteristics and specific uses. But what if I told you that two of these metals, which seem so different and are used in such distinct contexts, are constantly in a battle to see which one is more suitable for a multitude of applications? So, what is stainless steel and why is it so special? To begin with, let's talk about stainless steel, the material that you probably use every day without even noticing. It's found in pots, cutlery, appliances, kitchen sinks, and even in some structures of modern buildings. But what exactly makes regular steel into stainless steel? The magic behind its resistance to corrosion or rust lies in the addition of a key chemical element, chromium. It's the chromium that forms a passive, invisible, and very thin layer of chromium oxide on the surface of the steel. This layer acts as a protective shield that regenerates itself automatically if it's scratched or damaged, preventing the iron from reacting with oxygen and moisture, which are the main enemies of common metals. Besides chromium, other elements like nickel, molybdenum, hydrogen, and nitrogen can also be added to further improve its properties, making it stronger and more resistant to acids or high temperatures. And what are the main characteristics that make stainless steel such a popular choice? Well, the first and most obvious one is its excellent resistance to corrosion, as we've already mentioned. But stainless steel is not just beautiful and shiny, it's also a very durable material with good mechanical strength, which means it can withstand impact forces well without deforming or breaking. Its ease of cleaning and the hygiene it provides, since it doesn't retain bacteria and isn't porous, are essential qualities for the food and healthcare industries. In addition, it's a material that's relatively easy to work with as it can be cut, welded, and shaped into various forms, which makes it extremely versatile. And we can't forget that, compared to other high-performance materials, stainless steel has a very competitive cost, making it accessible for a wide range of applications. On the other hand, what is titanium and what is its history? Now let's introduce the challenger in our battle. Titanium. This metal has a name that already suggests strength, and that's no coincidence. It was named after the Titans of Greek mythology, who were known for their colossal size and power. Discovered at the end of the 18th century, titanium is a chemical element identified by the symbol Ti and is the 9th most abundant element in the Earth's crust. However, its extraction and purification are complex and expensive processes, which have historically limited its use to more specialized and high-tech applications. But what really makes titanium so special and sets it apart from stainless steel? Its most remarkable feature is the unbeatable combination of high mechanical strength with very low density. This means that, for a given volume, titanium is much lighter than steel, but maintains comparable or even superior strength. And what are the properties that make titanium so valuable and sought after? The exceptional strength combined with lightness is undoubtedly the most famous property of titanium. Just so you have an idea, it's about 40% lighter than steel, but as strong as some high-strength steels. This is a huge advantage in industries where every gram counts, such as aerospace. Just like stainless steel, titanium also has spectacular corrosion resistance, surpassing stainless steel in extremely harsh environments, such as salt water or when in contact with some strong chemicals. This resistance is due to the formation of a titanium oxide layer on its surface, which is even more stable and protective than the chromium-based layer in steel. But titanium has one more advantage: biocompatibility. It is one of the few metals that the human body does not reject, which makes it ideal for medical implants such as orthopedic and dental prostheses, cardiac markers, and even for the manufacture of surgical instruments. But now it's time for a direct showdown: stainless steel versus titanium in different categories. If the criterion is the strength to weight ratio, titanium comes out on top. It offers tensile strength similar to or greater than many stainless steels, but with significantly lower density. This is crucial for applications that require lightness without compromising structural integrity, such as in aviation and rockets. Stainless steel, on the other hand, is denser but still offers excellent strength and durability for most applications where weight is not a limiting factor. Now, when it comes to corrosion resistance, both are highly resistant to corrosion, but with important nuances. Stainless steel is excellent for everyday use and for less aggressive environments, resisting rust well when in contact with water and air. However, in highly saline environments like the sea, or when in contact with certain acids and chlorides, titanium shows its superiority. Its passive layer of titanium oxide is extremely robust and impermeable, ensuring a prolonged lifespan in extreme conditions, where stainless steel could eventually fail. And when it comes to cost, stainless steel wins by a landslide. Titanium is considerably more expensive, both to extract from nature and to process and shape. The complexity of the metallurgical processes to purify titanium and the difficulty in working with it due to its reactivity with oxygen at high temperatures and its hardness increase its final price. That's why titanium is reserved for applications where its unique properties justify the investment, while stainless steel offers excellent value across a broad market. When it comes to interacting with the human body, titanium is the absolute winner. Its biological inertness is unmatched, which means it doesn't cause adverse reactions in living tissues. This property has made it the material of choice for manufacturing surgical implants like screws, plates, rods, and joint replacements that can remain in the body for decades without any problems. Stainless steel also has medical applications, especially in instruments, but for long-term implants inside the body, titanium is the standard. In terms of ease of manufacturing, stainless steel is generally more cooperative. It can be machined and welded with more conventional techniques, although some types of stainless steel require specific care. Titanium, due to its high reactivity with atmospheric gases at high temperatures and its tendency to harden during machining, presents greater challenges in terms of manufacturing. It requires equipment and controlled atmospheres for welding and special tools for machining, which contributes to its cost and production complexity. Stainless steel and titanium are champions in applications that require resistance to corrosion. So, where does each of these champions really shine? Stainless steel is the ideal choice for household utensils and appliances because of its practicality, hygiene, durability, and affordable cost. It is also used in architecture and construction for facades, handrails, and structures where aesthetics and corrosion resistance are important, without the weight of the material being a critical issue. In addition, in the food and light chemical industries, it can be used in tanks, pipelines, and equipment that require hygiene and resistance to specific corrosive environments. Titanium, on the other hand, is indispensable for the aerospace industry in the structure of airplanes, rockets, and spacecraft, where the combination of lightness and high strength is vital for efficiency and safety. As I mentioned before, it is also used in medical implants, in hip and knee prostheses, bone screws, and dental implants, due to its biocompatibility and durability in the human body. High-performance sports equipment can also be made of titanium, such as bicycles, golf clubs, and tennis rackets, where lightness and strength offer a competitive advantage. In the naval and offshore industry, it is used in components exposed to salt water, such as heat exchangers and submarine parts. And in the heavy chemical industry, in processes involving acids and highly corrosive solutions. In the end, there is no universal winner in this battle of metals. The choice between stainless steel and titanium depends crucially on the specific application, the engineering requirements, the environment in which the material will be used, and of course, the available budget. Both are incredible materials, the result of a lot of research and innovation, and each has its own prominent place in the vast world of engineering. If you've made it this far and enjoyed the video, take the opportunity to subscribe. If you're not subscribed, leave a like and activate the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to get a mention in our videos. And for those who want their business accounting management to be as optimized as material selection in engineering, remember Contabilize, the largest accounting firm in Brazil, is ready to serve you and simplify your life as an entrepreneur, just like it simplified ours. And for more information, the link is in the video description. And have you ever had any experience with these materials? Which one impressed you the most? Do you think the cost of titanium is still the biggest obstacle to its more widespread use? Leave your thoughts in the comments. I want to know. Over here, there are 2 interesting videos you need to watch to learn more and satisfy your curiosity. And if you want to support us, leave a like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering enthusiasts. Take care, and I'll see you in the next video.